Hey there, everybody. My name is Phil LaMarr, and I would like to welcome you to NASA's Ask the Astronomers Live, where real live scientists come here to answer your questions about the universe. Now, keep in mind, they are scientists, not philosophers, so not every question about the universe. Now, if you want to find out about upcoming shows and see lots of fun astronomy videos, you can visit the Universe Unplugged website. Check it out. Some really, really cool stuff. Okay, today we're going to be talking about the nebula in the Orion Constellation and the making of an incredible 3D movie which flies through the nebula using images taken by the Hubble and Spitzer space telescopes. And since I know very little about all of that, we're lucky enough to have, chatting with us today, Jessica Harris and Frank Summers. Now, Jessica is a physicist that is specialized in studying the Orion star-forming region. Jessica, could you tell everybody a little bit about yourself?
Hey, Phil. I'm so glad to be here today. My name is Jessica Harris. I'm a small business owner and currently the program director for the Clark Scholars Program at the University of Virginia. I have over a decade of experience in education and public outreach, and Orion Nebula is one of my favorite nebulas to talk about.
Yay, I'm glad we picked your favorite nebula.
Thank you.
We are also lucky enough to be joined by Dr. Frank Summers, who is an astronomer who created the Orion visualization we're going to see today. Frank, tell the folks about yourself.
Nice to see you again, Phil.
Nice to see you.
I'm an astronomer at the Office of Public Outreach at the Space Telescope Science Institute in Baltimore, Maryland. What that means is that I work on all aspects of public outreach, from websites and educational programs and news releases, et cetera, for Hubble, the upcoming James Webb Space Telescope, and the upcoming Nancy Grace Roman Space Telescope. But my specialty is astronomy visualizations, so I get to call myself an astrophysicist. So astronomer who does visualizations, astrophysicist is my title.
I am very excited about that, except for the spelling of it. But it's a great word. Let's just leave it there. Okay, thank you guys both for being here with us. This is very exciting. Now, before we get to the visualization that Frank worked on, the 3D fly-through, why don't we get ourselves oriented first? Jessica, can you help us with that? Can you tell us about the Orion Constellation and where we can find the nebula within it when we're, say, looking up at the night sky?
Yeah, of course. So slide 1, we have a stellarium view of the Orion Constellation, aka the Hunter. The very top stars in his shoulder are Betelgeuse and the Orion star, and then his left ankle is Rigel. So look in the middle of where his belt is, the 3 bright stars there, and right below the belt is his sword. There's 3 horizontal stars there, and we have highlighted the 3rd star in the middle, well, the 2nd star, sorry, star in the middle, highlighted with the yellow arrow, is where the Orion Nebula lives. So you can view the Orion Constellation, not now, unfortunately, Phil, not today, but come November, beginning of November into February, you will be able to see this constellation in the night sky.
Wow, excellent. So the nebula is at towards the tip of Orion's sword.
Yes.
Good to know. Thank you, Jessica. Thank you for that. Now that we know where the nebula is, what's a nebula?
That's a great question. Something my kids would ask me. A nebula. A nebula is a ball of gas and dust out in space, either where a star has exploded or stars have formed. And we have the great fortune that in Orion, stars are forming. And another great thing that I get excited about is that not only stars are forming, but protoplanetary disks are forming. So that's where we'll talk more about that. But so Orion's really exciting because it's a star forming region really close to us here on our universe from Earth.
Oh, wow. So a nebula can be where stars have exploded or where they're forming, like the Orion Nebula.
Yes, yes.
Now, you also mentioned protoplanetary disk?
Yes. Yes.
Is that a
I
real
know.
thing, or that sounds like something from a comic book?
I know. It's a really, I always have to slow down to say it because it's a really long word. But slide 3 is a sample of it's actual a view of a protoplanetary disk observed from the Hubble Space Telescope. Slide 4, this is a great layout of several different types of protoplanetary disks that Hubble observed. 42 they actually discovered with Hubble. So as you see in the highlighted green image there, it's a disk. It's a dust disk that you see. And in that dust disk, Phil, is where the planets are actually forming. And this is happening within the Orion Nebula. And you'll see in the visualization that we pass by this protoplanetary disk.
Okay. So that's why it's proto. That's where the disk is being formed.
Yes.
The planets or stars are being formed?
So in this image that I just showed you, planets are forming in those gas dust rings.
Got it.
You can think of it as a baby solar system. Okay?
Yes.
Okay. Wow. That's
yes.
And Jessica, is this what you studied on working on your thesis?
Yes. So slide 5 is this is actually from the thesis paper that I released with my thesis advisor, Odell. So you see in the very the white, dark, thicker lanes is outlining the extended Orion Nebula, where we actually did another complicated word, Phil, but spectroscopy. But spectroscopy is basically breaking up light into its individual components. And so you can find out the composition in the extended Orion Nebula. So that's the specific work that we did. And the compositions we were studying were the temperatures and densities. So it was the first time that we could understand more fully what's going on in the extended Orion Nebula.
Okay, excellent. All right. Well, I feel oriented.
Okay.
And I can pronounce spectroscopy. Nope, I can't. But I can say spectroscope. So I think we're close enough.
It's,
Let's watch the movie.
Yes, let's do that.
Now, this is going to make what Jessica just talked about come alive. Frank, will you be our tour guide for this fly-through?
I will.
Thank you.
So we start out with the view of the Milky Way galaxy across the sky. And now we're going to zoom into the constellation of Orion, as you saw with Jessica's slides, and then zoom even further in to that middle star in the belt and in the sword, which is the Orion Nebula. So this is a survey view of the Orion Nebula, but we're going to fade in the Hubble view as seen in visible light. And then we're going to fade in the infrared view as seen by the Spitzer Space Telescope. So you can see the difference between visible and infrared. And that's a 2D comparison. Now we're going to do the 3D. So this is a 3D model in visible, which transfers to the infrared, which extends so much further out.
Wow.
Now we start to fly in. Okay. Now you get to see it in 3D. And the first thing we're going to encounter is what we call Orion's veil. It's a bit of gas that's been sort of blown out up in front of the Orion Nebula by the pressure and energy of the stars. And we transfer to visible light, and we come down and sort of skim across the gas of the nebula. Wow. Now we're traveling across, one valley going into this low valley here that leads to the star cluster at the core of Orion. This is called the trapezium cluster. And we fade back to infrared, and you can see that there's a big wide valley in infrared and many more stars, because a lot of the faintest stars aren't powerful enough to shine in visible light. Here we transfer back to visible light as we fly past the brightest stars in the cluster. And we're going to fly past one of those protoplanetary disks. And so here's our hero protoplanetary.
There it goes. Bye.
Oh, you just flew past a solar system in the making.
A baby solar system.
A baby solar system. So we're going to come back up here into what we call the high valley. And
wow, it's like the high desert.
And what you're seeing here is the dust and a little bit of the cooler material of Orion. So as I said, the visible light is hotter material, right? Thousands of degrees. And the infrared light is cooler material at hundreds of degrees. And so it's like a deeper layer underneath the visible light that extends much further out. And so as we turn back, we can see the main cluster in the center. And the extent to which that cooler gas in infrared extends way out from that cluster. That cluster is providing all the energy to power this nebula, okay, to heat this nebula. But it can only heat it to visible light emission temperatures over a much smaller region as observed by Hubble.
Yeah.
So you fly in and you get the full suite and feeling of the sweep of nebula there. And this is the wonderful team that worked with me. Just amazing people, very, very talented.
Very talented.
Wow. Yeah, that was gorgeous.
Yeah.
And I love that I got the feeling of having gone all the way across and then swinging around, you know?
Yes.
You got to be careful, Frank. I think somebody from Marvel is going to steal that from you and just steal the movie.
To be honest with you, a filmmaker already stole it. It appeared in a French film by Claire Denis.
No way.
Yeah.
Oh,
I actually had to re-render it for them so that it fit Hollywood's full Hollywood standards.
You had to put heels on all the sexy it up.
Yeah.
Wow. Actually, sorry, we're getting so involved in ourselves. But for anybody who's just joining us or missed the beginning of the show, we are discussing and looking at the Orion Nebula, a place where stars and planets are being born.
Yeah.
And we're talking about and looking at NASA's fly-through visualization of it based on images from NASA's Hubble and Spitzer space telescopes. It was, hopefully you got here in time for that. But if you were just looking at amazing colors and textures and didn't know what, it's Orion. But Jessica?
Yeah.
For the people who've been here and the people who just got here, can you tell us why, other than its amazing beauty, why should we care about the Orion Nebula? I mean, you guys as scientists, why is studying it so important?
Yeah, that's a really great question. And I just wanted to say to the visual, looking at these amazing images in movies, it's one of my favorite things to look for in these amazing movies, the visualization, people identify them. But so the Orion is really important because it's close to us from Earth's point of view. So it's 1,500 light years away from us, which is really, it's far away, but really close to us within our solar system from Earth. And it's the nearest star forming region to Earth. And so that means we get to study it in depth. I showed earlier image, if I can remember my image slides, image number 4 of the protoplanetary disk that we were talking about, Phil. Mm-hmm. There within that image, 42 images from Hubble were discovered, 42 protoplanetary systems were discovered with Hubble. And this is very rare. You actually don't get to see these protoplanetary disks forming in nebulas, but because Orion is so close to us, we get to really study it in detail. A total of 180 protoplanetary disks have been discovered in Orion. And why this is really important is because we get to really understand, how did our own solar system come to be? If we can study how it's forming within Orion, then we can really understand how our own solar system came to be. So it's really close to us. It's really valuable because we get to see protoplanetary disk forming, but also stars forming. So we can better understand what's happening in these nebulous regions.
Wow. So it's sort of like being, you know, if you were a history major, you'd want to live near Philadelphia.
Yeah.
I can go and look at the actual stuff.
Yes.
At least without traveling too far.
Yes. Yes. So this is the closest thing to us. We can study it in depth.
And does its nearness allow you to study more, get more information?
Yes. So Hubble, so in the image that we just showed in slide 4, Hubble's, with its amazing capability, is really able to see in depth. And we'll talk later on about the next telescopes are going to launch. But yes, being really close to us, Hubble's being really close to us, its capability of being able to see in optical and Spitzer's ability to see in infrared give us this depth of understanding of Orion that we would never have. So thank you. We need both images. So the image to the left is the Hubble Space Telescope that you saw. And then Frank was talking about the Spitzer Space Telescope that's really giving you a deeper, broader picture of Orion that we would never be able to see. And so because it's so close to us, we get to get these amazing images.
Got it.
And it's the importance of multi-wavelength astronomy.
Yes.
Too much of the public thinks Hubble's the only telescope up there. No, we need lots of telescopes in lots of different band passes to get a complete picture of the universe.
Yes.
But doesn't that make it much harder for people to get their astronomy degrees now? Because in the old days, when there was just one telescope that was just glass, you guys could have probably done it in like 6 months, right?
No.
It does mean you have to specialize.
Yeah.
X-ray astronomers and radio astronomers, they speak different languages sometimes.
Yeah, but we're all needed. It's like different languages being able to come together and different perspectives to be able to see something that we would never be able to see before.
Excellent. Well, speaking of specializations, Frank, can you tell us a little bit more about, I mean, you talked to us about what we were seeing, but can you tell us how you created that?
Absolutely.
The 3D fly-through.
Things to talk about. So we can bring up slide 7. This is where we start. We take a look at the astronomical object. We bring in the experts. We analyze what the geometric structure of it is. And we use these geographic terms like plateaus and valleys in order to describe it. On slide 8, we show you what we do with that idea is we then take it into a 3D modeling program, the same sort of programs that Hollywood uses for their movies,
Right.
but we're using this for science. And then we sculpt out the surface of the nebula, including, for example, places that we don't actually see from Hubble. We have to sort of interpolate as to what is inside there, like that big cave down.
With the stars.
Wait, the near one or the far?
The valley.
Actually, let's go to slide 9, and I can show you. You can see that cave to the right, lower right. That all of this has to be extrapolated from the data set in order to be able to because that is blocked from our view from Earth. Okay. Yeah. So this surface just comes up as looking hard. It looks like a video game. Okay. It doesn't look like a nebula because nebulas are gas.
Looks like a marshmallow.
Right.
Slide 10 shows you what happens when we add in millions of point clouds to give it that gaseous feel. This is the really computationally expensive step here. All right, to get those millions of point clouds to make it feel gaseous on that surface. Slide 11 shows that we bring in the stars of the Hillenbrand catalog, which is all the stars inside Orion. And then slide 12 shows you that we bring in all of those protoplanetary disks along with the bow shocks. There are winds flowing around creating these bow shocks in there, as well as, it's hard to notice, but there are the background stars, which is the complete Hipparcos catalog of about 110,000 stars nearby us in the galaxy. So slide 13 shows you a view on the left of this visible light model of the Hubble, based on the Hubble Space Telescope data. And we built that back in 2010 for the film IMAX Hubble 3D. Then we needed to do it again for the infrared for this project. We want to be able to look at the visible light and compare what we see in infrared light. So we effectively had to start back over again and rebuild the whole thing using all the catalogs from the infrared light and doing it all. So here you can see the two models that allow us to compare and contrast what Hubble and what Spitzer see in the Orion Nebula.
Wow. That's amazing.
Yeah, quite a lot of work over many months.
Yeah, well, it's so wonderful. I hope people are really appreciating what they're seeing. I mean, because Jessica, you said that's 1,500 light years away.
Yes.
And you guys are adding layer upon layer.
Yes.
And that's what you were saying about the millions of points.
Yeah, I mean, this is scientific data that's going into this modeling.
Yes.
It's not just artists making up whatever they want. Okay?
Yeah.
And that's what people often don't appreciate about some of the visualizations. The difference between an animation, which is artist drawing, and a visualization, which is a science-based data visualization. That's what we strive for.
And the parts that, some of the parts that Frank was showing is actually what we study. So he's adding in these extra components and the scientific data, and the research that I did just add depth to that. So actually he could determine like what the actual density and composition of those regions are. But within his visualization, you could see stars that had already formed, stars that were forming, and the protoplanetary disk, all in one system. It's really amazing.
Yeah. Well, it's funny. There was a comment that came in from Twitter before the show. Gingerific_KNH said, I wish this could be projected into one of those rooms that wraps around you so that all I can see is this.
Yes, I want that.
I've got it for you, Gingerific. Let's bring up slide, what is it, 16, slide 16. We have those rooms, and in astronomy they're called planetarium domes, right? And because we have this full three-dimensional model, we can fly cameras through it and create a dome visualization for it. So we have both visible and infrared dome visualizations. Furthermore, if you put on the VR goggles and you can look in 360 degrees around, we've also created that a VR 360 visualization. Yeah, you want to be surrounded totally by the Orion Nebula? Hubble gotcha. All right, Spitzer gotcha too as well.
Yeah, come on.
That's amazing. All right, we have a couple of questions from our audience, which means people are watching. So, you know, check your teeth for lipstick, Frank. Our first question is from Marina Kunkel. She says, so relative to us, most of the gas is located behind the cluster, or is that just an artifact of the visualization? Oh, that's a good question.
Well, the gas of the nebula is spread out perpendicular to our line of sight. Okay, so we're looking at it, you know, like this, and the gas is all spread out. But the gas of the nebula, the star cluster actually eats away the gas. The high energy radiation, the ultraviolet radiation from the bright stars eats away the gas and allows us to actually see into the nebula. So there is gas behind the star cluster. There's also gas all around the star cluster. But yeah, you wouldn't have gas in front of the star cluster, except for that thin little veil, because the energy from that bright cluster has actually eaten away that gas and ionized it.
Really? Okay.
So that the cave that you were seeing, there's these really bright stars that have built that cave that he built in one of the slides that he showed. So that cavity that you're seeing is actually from the stars that are eating away that gas.
Wow. Okay. Well, there you go, Marina. Thank you for your question. And now we have one from Kevin Hainline. And the question is, will there be a bigger infrared telescope than Spitzer so we can get better pictures of Orion and the baby stars in protoplanetary disks?
Great question, Kevin. So we're going to go to slide 6. This is one of my favorite telescopes to talk about, the James Webb Space Telescope that will be launched sometime next year. It's going to be an infrared telescope. And one of the science goals for James Webb, JWST, is to actually study star-forming regions and protoplanetary disks. And so, Phil, you know how we showed you the disk of the protoplanetary systems forming? James Webb will actually get to see through those disks and actually see the stars forming.
Really?
So yes, that's on the horizons. I'm really excited about the James Webb Space Telescope.
And that was one thing we weren't able to put into the infrared visualization was those protoplanetary disks, because Spitzer unfortunately doesn't have the resolution to see them and to see into those forming planetary systems. So we're really waiting forward to redo this visualization yet again with WST data.
Yes, I can't wait.
And it'll match the Hubble resolution.
Now, Frank, did you mention that there was another telescope in addition to James Webb that's pending, or?
At the Space Telescope Science Institute, we're also going to be the support home for the Nancy Grace Roman Space Telescope. Yes.
Excellent.
And that will also be an infrared telescope like James Webb, but it will be a big survey instrument. So it will take the infrared view of Hubble, and it will expand on that by a factor of 100. So every image from the Roman Space Telescope will be like, 100 times as many the area of what Hubble can see.
Yeah.
Wow.
That's going to be a lot of data.
Lots of data. You're going to have to astrovisualize a whole bunch.
Oh, yeah. We're going to need a bigger disk. Hard disk.
All right. We have another question. From Marina. Is it just a rasterized movie, or is it possible to navigate the 3D model in some other software?
This is a rendered movie. Yes, rasterized, rendered. It is because it takes on some of the longest sequences of it take about 90 minutes per frame. All right.
Oh, wow.
Frank, what's rasterized? What does that mean?
Rasterized means rendered, turned into pictures.
Oh, okay.
From the 3D model into actual pictures. Now, in my own software that we use to create it, we have to, of course, create the camera path, and that is interactive. But it doesn't have any near the richness of the rendered images of the movie. And so if you were going to turn this into a computer game, you'd be talking about how many frames per second you get. Mm-hmm. Our renders are in seconds per frame or minutes per frame, or at sometimes hours per frame. Okay, so it takes a very long time to render these sequences.
Wow.
Yeah,
that's amazing. Let's see. I had a question.
Yes.
I'm watching the infrared visualizations. The infrared images and the ones from Hubble, the visual light images. How close are the colors in the movie to the ones that I would see with my eyes if I were able to get 1,500 square light years away?
It's a hard number to remember. So
I'm working on it. I'm talking to Jeff Bezos. He's building a space ark for me.
Okay, great.
Yeah.
Why don't we bring up slide 17?
17.
Yeah, and you can see on the left, you've got the Orion Nebula from Hubble, and on the right, you've got the Orion Nebula from Spitzer. Now, Spitzer observes in the infrared. So, Phil, can you tell me what color is the infrared? You can't see it, right?
No, it doesn't
have a natural human eye color. So, first of all, that's easy to think. Second of all, Hubble and Spitzer only take black and white images.
Mm-hmm.
Yeah. So what you see here in this color mapping, this is, by the way, from the wonderful website AstroPix, where you can see a tremendous number of really great astronomy images. And it provides the details of the colors in them. So on the Spitzer image on the right, you can see that there are 4 infrared bands that are mapped to red, green, light blue, and darker blue. Okay. So each of those images starts out as a black and white image that then gets transformed into these colors to present to the public. Now, on the Hubble one, we think of these are colors that you possibly could see. And in human eye sees red, green, and blue, right? And you add red, green, and blue images to make a color image. Well, here we've got 5 band passes. We've got a blue band pass, a green band pass, and 2 red band passes, plus a very narrow band filter called H alpha. And this only records the light of a specific energy from the hydrogen emission line. And so we combine those colors to create we combine those different filters, assigning them colors in order to create the images. So it's not what the human eye would see, but then again, these are scientific instruments, and they're supposed to see a lot more than what the human eye can see.
Got it. All right. So once I get my cyborg eyes, that's what Now, we're about to wrap up, but would you guys like to share any closing thoughts? Let's see. Frank, what do you like most about your job? Other than making up words.
I love making up words, but what I like is being a science geek. I'm, an astronomer. I'm a geek, but I also have a long history of artistry in it. I've been a dancer all my life. I've done choreography. And doing this visualization allows me to take the science and the art and combine them into an expression for the public that gives them a appreciation for what I see as an astronomer when I look at these images. And it helps them build what I like to call a mental model of what the three-dimensional structure of these scientific observations is.
Excellent. Now, Jessica, can you bring it home for us? Do you have some thoughts you can share about how people can get involved with astronomy?
Yeah, that's a great question. So I think it's really important to remember that it takes a multitude of different people and different professions to make what we're doing today come to life. So you need your engineers, you need your artists, you need your science writers, you need a whole plethora of backgrounds and expertise to bring what we're doing to life. So I said, I love talking about James Webb Space Telescope because I literally spent 7 years of my career talking about James Webb, but I went from classroom to classroom giving talks. And when I first went and I had asked people to raise their hand, had they heard about James Webb? No hands were raised. But 7 years later, students knew about the James Webb. Now it's part of our pop culture. It's within everything that we do. And so like that takes time and it takes people. And there's a lot of people behind the scenes that you'll never see. They'll never be on a broadcast, but that are so important to do what we do in education and public outreach. And so I just wanted to share, like, if you're interested in astronomy, don't hold yourself back because you don't feel like you're good enough in the sciences, or you don't feel like you have the astronomy or physics background. We're all needed. So that's my final thoughts.
Oh, wait.
Yes.
Before we wrap up, we just got something in here from Margie Stratton. Jessica, do you have any advice for teen girls or college age, for example, who want to become astronomers?
Yeah, that's a really good question. Thank you for that. So the advice that I would give is first, really understand what you're wanting to do, build your mentors around you. And so when I was coming up, it was really important to have a plethora of mentors that were around me. So find your mentors, find your champion, find the people that are really going to advocate for you, because this field can sometimes be really hard. Sometimes can be really lonely, especially as a woman, especially as a Black woman within the field. But find your support systems and keep those around you as you're pursuing this degree.
There you go. Support systems. That's Margie. I hope that question helps. It's all right. Thank you, Jessica Harris, Frank Summers. Thank you guys for being here with us, and thank you both for your work in astronomy.
Yeah.
This is, I feel like, having a universe perspective, being able to see beyond our noses, beyond our country, beyond our planet, beyond our solar system, is so important for people.
Yeah.
So thank you guys so much.
Thank you.
And thank you guys for joining us and to learn more about the Orion Nebula and how NASA created these 3D visualizations. Now you can see the images that Jessica and Frank showed you, and so many more than that, by going to AstroPix and searching for Orion Nebula. There's the link right there. Write it down quick. Now, of course, you can watch the Orion fly-through as well as all of our other videos at the Universe Unplugged website. Or you can just click on the link in the comments. There's a link. There's always a link. Now, I want you to subscribe on YouTube or follow us on Facebook, and then you will be the first to know when we'll be back with our next chat in September. And even if you're not someone I went to college with, you can still come and watch. All right. Until next time, I'm Phil LaMarr, and this has been Ask the Astronomers Live. Thanks for watching.